starting with the series, binomial series and arithmetic series and geometric series. So here we have a binomial theorem which expand in this form, and some geometric and arithmetic progressions are also the part of this course. So Pascal triangle, whenever we open higher order polynomials, for example a plus b q, we express it in this form. So here we have coefficient 1 3 3 1. So here we have 1 1 for first order. For second order we have 1 2 1, and for third order we have 1 3 3 1. So here we have 1 2 to get 3, from 2 1 to get 3, and from 1 to we have this one. For power 4 we have this 1, and this 1 and 3 gets 4, then 3 plus 3 gets 6, 3 plus 1 4, and this one 4. Similarly for the others one. So we have this kind of Pascal triangle, this 1 1 1 2 1 1 3 3 1 1 4 6 4 1. We have 1 1 1 2 1 1 3 3 1 1 4 6 4 1. Similarly for this one, 1 4 5 here, 4 5 10 here, 6 4 10 here, 4 1 5 here. So again 1. So for the next one we have this 1 plus 5 6 here, 6 plus 10 15, 10 plus 10 20, 10 plus 5 15, 10 plus 1 6, and then finally 1. So this is the Pascal triangle that we have obtained by these simple methods. So this is Pascal triangle. So again, so higher order polynomial up to the higher order, I have included 2 more rows here. Similarly, more rows can also be added. So this is the one of the way the Pascal triangle works: 1 4 10 and 20. So this is the way. So we'll start from exercise 11.1 from here. Write down the 6th and 7th rows of the Pascal triangle, and then we will solve some Pascal triangle to find the expansion of this A to L. So let's start example 1 for problem number 1. For Pascal triangle we have 1 1 1 2 1. This 1 1 gets 2. This 1 plus 2 gets 3 here. So same 1 is here, is expanding on both sides, and the middle term 1 plus 1 2, 1 plus 2 3, 2 plus 1 3, 1 1 plus 3 4, 3 plus 3 6 here, 3 plus 1 4 here, 1 again here, and then in the next row we have 1 plus 4 5 here, 4 plus 6 10 here, 6 plus 10 6 plus 4 10 here, 4 plus 1 5 here, and again on the other side we have 1 1. For the next Pascal row we have 1 plus 5 6, 5 plus 10 15, 10 plus 10 20, 10 plus 5 15, 5 plus 1 6 here, so 1 1 on the other side. Similarly for the next row we have 1 6 7, 6 15 21, 16 15 20 35, 20 15 35, 15 6 21, 6 plus 1 7, and then 1. So this is the way that we added up to the first row, second, third, fourth, fifth, sixth, seventh, eighth. I have included up to 8th row. So it has been asked I think 5th or 6th, but I have included one more row. I used Pascal triangle to expand this. So here we have indices 3, so index 3. So the third row in the Pascal triangle is 1 3 1. From this we have this 1 3 1. So in this way we can expand it. Here we have 3 3 1, and here we have x cube for this first one, then 2, then 1. Similarly it will increase 1 1 2, and then 3. So this is one of the way that it can be opened by the Pascal triangle. This 1 minus x, index 4, so the 4th row in the Pascal triangle, 1 4 6 4 1. So we can write it 1 4 6 4 and 1. Here we have write a power 4, a power 3, b power 1. This is b, this is a, this is b. So with b here is in 6, 1 power 2, and a power 2, b power square, a power 1, and b power cube. And similarly for this fourth one, the b power 4. So here b is minus x. So everywhere where b is given as minus x. So we put minus x in place of b and guess this results. So this is simple. And for the other part, fourth row, so similarly for this one, d, that's 5 for this, and then. So we have solved it all. This one for k, next fifth row means we have this 6 terms will be there. First 5, 10, 10, 5, 1, and in place of a we have this, in place of b we have this 2 upon x. So we have, and then simplified it, we get this result. For this we have this kind of results. For problem number 3, for the coefficient of x cubed in expansion of this, so for triangle, for problem number 3 we have to expand, find the coefficient of x3. x3 coefficient means we will find the coefficient of x3 for these all terms. So for x3, we have this is x4, so this is x3 means here we will write 4 for the index number 4. We have this Pascal's values, so we will write here 4, and then in place of a we will write a here. This is x, and for b value we have 4, 1. This is n minus r. So this term is third term, so this is n minus r, and this is r. R is 1 and n minus r is 3. So this is 4 for the 16 and x3. This is the term coefficient of this one. So similarly for this one we have 5 here, so we have 6 terms here, 1, 2, 3, 4, 5, 6. And for this second term would be x. Here we have x 0, here we have x1, x2, and here we have x3. So x3 here, and the first a is power 2, that is n minus r, and r is 3, n is 5, n minus r, 5 minus 3 is equal to 2, and here we have r value, that is 3, so we can write it down. Similarly for this one, for this series, here this r is 3, so this would be the term. 4, 3 minus x, this one, this coefficient is here, this a is here, and the b is, so we get this one. But similarly for d, we have the last one is, we get this. For E, F, and G. For G, H, this can be written on, this is 4, so we have this term, and here we have 4, so this one would be the x3 term for this, and so we have this value. Now problem number 4, so this was easy. For problem number 4, we have to find the value of a, b, and c. This is a, b, and c are the coefficients of x power 0, x power 2, and x power 4. So find the value of a, b, and c of these polynomial. So whenever we open it, we will get some kind of results to get these values. So for expanding this, and we'll compare and we'll get some values. So for problem number 4, we are here. This we have to find this a, b and c. So for expansion of this one, 4 plus x5, here we have Pascal expansion. This is partial expansion of this first 4 plus x5 power 5, and for the second one we have this. Here we have a negative sign, here we have a positive sign. So when we expand and simplify, we get this kind of values. So this will cancel out because plus minus minus, so this term will be cancelled, and similarly for this term will be cancelled, and this term will also cancel. So we have this 40 x4, because this minus x power 4 will be positive. All even numbers, odd numbers will be cancelled out by the upper one. So we will have this 2, 4 power 5, 20, 4 power 3, 10 plus 10, 20, and here in this case 20, 20 means 40 x power 4. So we have this value. So here we have a is equal to a means 4 power 5 into 2, this is a, and b is 20 into 4 power 3, and c is 40. So this is further simplified to write down like this. So similarly for this one, so a and b and c are calculated here, and we have obtained a, b, c and this. So now number 5, so we have to expand it. So we have this one and this, we expanded it like this, and by multiplying this with this one, we have obtained this. So this is simply the expansion of problem number 6. We have to find the coefficient of x is 96. Coefficient of x is 96. We have to find the value of a, coefficient of x. So we have to write down where the coefficient of x will be 1. So for this term, this term would be the where the coefficient of x would be 1. So we are going to write it 3 power 2 using the Pascal's triangle. We are writing down here, and we have this value. By comparing coefficient, we can get the value of a. So this is simple, and a is obtained as 8. So for problem number 7, we have this kind of expansion using a Pascal series, and we have expanded and we have obtained it as this. For using this one, this relationship to solve this problem, so we have placed all these values instead of x, we have write down this under root 5. So it becomes easy to solve. Now expand this, we have expanded it open. Now part B, we have this. Using the same, in place of x, we can write down under root 3. So we get some values. Similarly for minus 3, we get 6 values. So 1 plus 3 plus 1 plus 5. Similarly, this can easily be solved. So 2 minus x power 2 power 4, we actually solved it. Coefficient of x6 in the expansion of this. So we have to expand these things. So we have this value, and we have to expand it by using Pascal series. So as a result of this Pascal series, we have obtained it in part A, and we will multiply with this one, and we have to find the coefficient, which is this. So where we will get this coefficient, this x when multiply with this one and this one multiply with 1, we will get x power 6. So this 1 when multiply this, we will get this value, and this 3 x power 2 multiply with this one, we will get this x power 6. So when we simplified it, and we will get this. The coefficient of x power 6 for this expansion would be 61. it was the required value. So coefficient of x in the expansion of this, so we have obtained this. The coefficient of x is by solution we have obtained this. Here we have a coefficient x because this x power 2 and x power 3 will cancel out, and resultant will get as x as a this value. So this is 90. So on simplification we can obtain this one. Similarly for the 11 questions, question number 11. Find the term independent of x in the expansion of this. So we will find the term will be independent of x at somewhere. So we'll see how proceed. So 11 term is independent. Term independent of x we have to obtain in this term. So we will expand it by using a Pascal triangle, A and B. This is A, this is B. Using expansion, we find that here this value, where this is a square and this is power 1, actually this is square will cancel out and we will get an independent term of x. So this is independent of x, that is 3/4. So it's very easy. So now we proceed to the 11.2. So 11.2 we actually have a binomial theorem. Where a binomial theorem we can write down the coefficients of each Pascal values in terms of this NCR. So this is N, this C, and this is R. So for the first term we have N5, C0 for A plus B whole power 5. We write down like this. So this, for this value we have like this: 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. 5C5 means 1 and 5C0 means 1. So we can write down NC01, NCN is also 1. So this value will be obtained like this. So we will solve it by using binomial theorem. So for exercise 11.2, writing the following rows of Pascal triangle using combination notations, row number 3, 4, and 5. So we are writing it. Row number 3 is write down as 3C0, 3C1, 3C2, 3C3. Row number 4, 4C0, 4C1, 4C2, 4C3, 4C4. And similarly for row 5, 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. And for next problem we have to expand 1 plus x power 4 by using a binomial theorem. So this is one is 5C0, 5C2, 5C1, 5C2, 5C3, 5C4, and this is A, this is B, A, this is A, n minus 1, and this is 1, n minus 2, this is 2, n minus 3, this is 3, n minus 4, this is 4. So we can write down like this. So similarly for this one and for this one, we've all solved it using this simple technique. For find term in x power 3 for each of the following. So we have to find in this expansion we have to find x power 3, the coefficients of x power 3. So we will see this. Here we have x, so the term with 5C3 will have this x power 3. So we will have this. So we have obtained it by this. For this one we have this r is 3. For r is 3 because this is x power 1 inside with whole power, so we can write it like this. So by solution we have this 8, 7, 5 and then 5 factorial or 3 factorial, n, or in C value we write down n minus r factorial and r factorial. So n minus r factorial is cancelled by this n minus r factorial, and here is n and this is n, r value. So we have write down n 8C3 can be write down like this. So this is x power 3, and this is, on simplification we obtain this. And similarly for this one, this is, we have to obtain value with x power 3 for every one. So this fourth one, first three terms, we have to evaluate the first three terms here, 10C0, 10C1, 10C2. So here this one is 1 power x, this is a, this is a power 9, b power 1, a power 8, b power 2. So simply we write down it here like this, and we obtain three terms. Initially three terms, first three terms is like this. 4-1, 4b simply for this one, 1, 2, 3. Here is D, E, F, G, H. Now the fifth problem, problem number 5. Write down the ascending power of x for the first 4 term in the expansion of this. First 4 term of, we have to evaluate the first 4 term of this, and in the part 2 we have to find the coefficient of x cube in the expansion of this. So we will utilize this expansion here to find out this coefficient of x power 3 in a part B. This is question number 5. We have expand this to obtain this value, and we will use it here in this place, and we'll find the value coefficient of this. So we have obtained this by multiplying this one and then this one to obtain this expression, and then combine whatever and we combine. So we have obtained this. So similarly, so the coefficient of x power in the expansion of this is this. Similarly for problem number 16 or 6, we have to find we have to write down in ascending power of this first term of this, first 4 term of this one, and then write down here this first 4 term and then multiply it to get the coefficient of this x power 3. So it's easy. For problem number 6, so we have expand this one up to 4th term, and then we have write down this 4th term here and then multiplied it with this one to get x power 3 coefficient, which is this 377. So, similarly for the 7th problem, we have to expand this one. We expanded it and then multiplied this with this expanded one to get the coefficient of x power 3. So we multiply and get the coefficient of x3 as this. So for 8th problems, we have this one, and find the coefficient of x power with the multiplication of this expansion with 1 minus 3x plus 5x squared. So we'll multiply it with this one with the expansion of this and get this result, and so x power coefficient of x power 2 is obtained as 47. Problem number 9, this is simple. We have expanded up to the 4th term, 1st, 2nd, 3rd and 4th term, and by using this we have to apply this into this one. We have obtained y power 3 as this. Similarly for the problem number 10, Yes, very typical one. This is A, this is y minus y square is considered as B. This is B. Okay, so we have to go for this term where we have y power 3. In this first term we have no y3 because this is y and this is y square, so we consider this term and this one. So for these two terms y cube is present, so we expand these two and we have obtained some results like this. Problem number 10. The term independent of x we have to find. So here we have when x power 6 and this is x power 3, this becomes x power 6 and we cancel out, we'll get some coefficient without x. So this is 21.2. And question number, challenging question 12. When 1 plus ax power n is expanded, the coefficient of x power 2 and x power 3 are equal. Find a in terms of n. When these coefficients x power 2 and x power 3 are equal, we have to find the value of a and n. So this is our challenging problem. So we have obtained x power 2, this one is x power 2 and this is x power 3. The coefficient of x power 2 is this one and this a square, and here a power cube is also the coefficient of this. So we have write down the coefficient of this one and coefficient of this. Okay, so we have write down these two terms and the coefficients are used here. Coefficient of this is used here, and we have obtained solution as this. So this was very good problem, may be asked in final exam. So now we will cover 11.3 and the remaining part in next session.